Okay guys, welcome to our very first video lecture. I'm going to be, you can't see this, but I'm going to be, let me show you actually. I'm going to be writing on my laptop like so and talking to you like so, and hopefully this will work for you. So let's see how it goes. Bye. Okay guys, this first one is a little bit of a review. I wanted to go back over it just because it's been like literally 3 to 4 weeks. So let's look at the first one. All right, so the problem says if the function f of x is x to the fifth plus 4x plus e to the x, then find f prime of 0 and f prime of 1. So let's see. Let's use red. So first we have to find the derivative, which is the slope of the tangent line. So when we have a power rule, which is like x to the fifth, we bring the power down, so it's 5x, and the lower power is minus 1, or 4. Plus, we have 4, and x that has x to the first as the power, and the derivative is 1x to the 0. Plus, the derivative of e to the x is e to the x. So this simplifies into 5x to the fourth plus 4 plus e to the x. So we have to find now, let's see, what do they want us to find? They want us to find f prime of 0, which is the slope of the tangent line at 0. So f prime of 0 is 5 times 0 to the fourth plus 4 plus e to the 0, which is 5 times 0 is 0. So it's 4 plus 1, which equals 5. So what does this mean, guys? What does this mean? Well, when we find a derivative, we find the slope of the tangent line. So that means, I'm going to do my best to draw it. Guys, that is literally the worst tangent line I've ever drawn in my life. Not much different from class. Okay, I'm also trying to draw in a slant here. So here's the point, and here, that's okay. That would be the slope of the tangent line, and we know the slope of that line is 5. Now we need the slope up above right here. So we have a second tangent line, and we need to find its slope. And it looks to be a little more steep, but let's go ahead and find it. So we need f prime of 1. So it's 5, 1 to the fourth plus 4 plus e to the first, which is going to be 5 plus 4 plus e, which is 9 plus e. And if you put that in your calculator, that is approximately 11 point, what did I get? 7183. So this slope is about 11. So it is quite a bit steeper than the first slope. So if you were going to make the equation of the tangent line to either one of these points, you would then take the point that I labeled on the curve, take the slope, and create the equation of the tangent line. All right, let's look at the next one. Okay, so this starts the meat of the lesson. And we're going to look at what do we do when we have two functions multiplied together and we need to find the slope of the tangent line. Obviously, we can always use our calculator or Desmos to figure it out, but if we have to do it by hand, what do we do? So look at the problem here. We have h of x equals, let me go to my highlighter, h of x equals this function, which is two things multiplied together. Now, before in the past, we, since we didn't know how to do this, we would multiply it out. So we had h of x, and we would multiply x squared times x and get x cubed, and then x squared times negative 3x squared. And then to find the derivative, we would take the derivative, which would be 3x squared minus 3 times 2x. So we get 3x squared minus 6x. Okay. But here's the thing. What if there was a faster way? Spoiler, there is a faster way. Okay, so look what I have over here in red. I said, well, if you have two things that are multiplied together and you need to find the derivative, can you not just find the derivative of one, the first one, and then multiply that by the derivative of the second? So let's test it out. So I want you to stop the video right now, and I want you to test it on your notebook paper. So this is the part where you take notes. So I'm going to pause, and you're going to stop and try it for yourself. Okay, now I'm back. Hopefully you aren't lying right now, and you actually tried it on your own. So let's try this. So h of x, what did we have for h of x? We had x squared, that's their first function, times x minus 3. So what if instead of multiplying it out, we just found the derivative? So what if we did the derivative of the first one, which is the derivative of this, 2x, times the derivative of this function, which is 1x to the 0 minus 0. So that ends up being 2x times 1, 2x. All right, guys, so it didn't work, did it? These are not the same, so that was a no-go. So now let's look at what we can really do to figure it out. Okay, so here is the real rule. Now, I know that you're looking at this and it looks like a lot of mumbo jumbo. This is kind of how I talk about it in class. So here's the thing. If you have if you have a function that is made up of two functions multiplied together and you want to find the derivative of that, you do what, if you look on the slide, the second part that is highlighted, you take the first function, leave it alone. Multiply that by the derivative of the second, plus the second function, leave it alone, multiply by the derivative of the first. So I'm going to write that out in words for you, and I want you to copy it to your notes. Okay, so the derivative, let's call it h prime, of a product of two functions. So let's say h equals two functions multiplied together. You take the first function, leave it alone, and multiply that by the derivative of the second function, plus the second function, whatever it happens to be, leave it alone, and multiply by the derivative of the first function. Okay, so layman's terms. You have two functions multiplied together and you need the derivative. Take the first function, leave it alone, multiply by the second derivative of the second function, add, and then take the second function, leave it alone, multiply it by the derivative of the first function. I usually in class make my students say this a bunch of times over and over. I'm not going to do that because I can't make you do that. So you're off the hook. All right, guys, this is where we test out our new thing, our derivative, and it's called the product rule, by the way, because we have product means multiplication and we have two things multiplied together. Okay, so let's look at this. We have 5x squared times x cubed plus 2. So if we are going to find the derivative, that would be y prime or dy dx. And the rule is take the first function, which is 5x squared, leave it alone, and we're going to multiply by the derivative of the second function. The derivative of x cubed is 3x squared. The derivative of 2 is 0. Plus, okay, so that's the first part. Now we take the second function, leave it alone, and multiply by the derivative of the first function. And the derivative of 5x squared is 10x. And now I'm just going to simplify this. So y prime, we have 5x squared times 3x squared plus x cubed plus 2 times 10x. Now, could I multiply this out further? Absolutely. But there's really not a point to doing that at this point. I said point twice. There's really not a point in doing that. If you're just using this to find the slope, at this point, you could plug in any number you wanted. And I said point again. So I'm going to stop so I can stop saying point. Okay, for this next one, what I'd like you to do is to take a minute, write down the problem, and attempt it on your own. So just pause the video and try it on your own first. Okay, I'm going to pretend you paused it. I don't know, you could be lying to me right now. Okay, so we have h of x, which is a multiplication of two different functions, 4x cubed times x squared. It would be super easy for us to multiply these right now and find the derivative. That's why I wanted you to try it on your own, because you can easily multiply them right now and find the derivative that way. But instead of doing that, I want us to do the product rule. And so I'm going to reiterate the product rule. It's first function times the derivative of the second plus the second function times the derivative of the first. So let's try it. So h prime of x equals the first function, which is 4x cubed, times the derivative of the second, which would be 2x, plus the second function, x squared, times the derivative of the first, 12x squared. And that's our answer. Could we simplify it? Absolutely, but there's no need to do it right now. So if you did multiply it out though, you would get what? 8x to the fourth plus 12x to the fourth, which would be 20x to the fourth as our derivative. And let's pretend this was 4 weeks ago, before you knew. You would have said, well, h of x is 4x cubed times x squared, which is 4x to the fifth. So then h prime of x would be 4 times 5x to the fourth, which would have gotten you to the 20x to the fourth. So suppose you're wondering to yourself, well, who cares then? Can I just multiply it out? Not always. And also, what if these were to a power? What if we had 4x to the third to a power? Or the other example. And we're going to look at those probably next week, but they can get more difficult and more intricate. And so that's why we need to know this rule. Okay, this one I want you to try on your own first, again, like before. And I'm just going to go ahead and put the derivative on here. So it's first function times the derivative of the second plus the second function times the derivative of the first. So hopefully you can stop the video and check your work. All right, I chose this example because it's not super pretty. It does involve some negative exponents. So let's look at that one. So take a moment, write it down, try it on your own, and then you can check your work. So the derivative, leave the first one alone, times the derivative of the second, plus the second one, times the derivative of the first. Now I'm going to go back over that derivative. When you have x to the negative 2, you bring the negative 2 down in front. And so you bring the power down in front, and the new power is 1 less. And the old power was negative 2, and negative 2 minus 1 is negative 3. Another thing I want to talk about, doesn't matter if I did first times the derivative of the second plus second times the derivative of the first. What if I done the second times the derivative of the first plus the first times the derivative of the second? Doesn't really matter which one you do, just as long as you keep one steady, multiply by the derivative of the other, plus the other. And because an addition sign is commutative, it doesn't matter which one you do first. So that one doesn't matter. Something we're going to be learning later in the week, it does matter the order, and we'll talk about that when it comes to that. Okay. All right, guys, this is the last example of the lesson, and it's one where we're going to find the tangent line. So in order to find the tangent line, we need the slope of the tangent line, which is the derivative. So let's look at our function. Our function is 2x plus 5 times 2 to the x. So to find the derivative, we need to take the first function, 2x plus 5, multiply that by the derivative of the second. And the derivative of 2 to the x is 2 to the x natural log of the base, which is 2. So that's the first function times the derivative of the second, plus the second function times the derivative of the first, which is 2. Now, that is our slope of the tangent line, but we need the slope at a specific point, 1. So we need to find f prime of 1. So we plug 1 in for x. So 2 times 1 plus 5 times 2 to the first, natural log of 2, plus 2 to the first times 2. And if we simplify that, we will have 7 times 2 natural log of 2 plus 4. I put that in my calculator, so I can either put it in my graphing calculator, or you can use Desmos on your cell phone. So here's what I got. When I put that in my calculator, I got approximately 13.7. So now I'm going to make my tangent line. So for my tangent line, well, really, for any equation of a line, you need two things. You need slope and you need the point. I already gave you the point. I said the point is 1, 14. And now we know our slope is 13.7. So I'm going to use the point slope equation, which is y minus the y value of 14 equals the slope, 13.7, x minus the x value of 1. Now I'm going to solve that. I don't have a lot of space left, so bear with me. So I get y equals 13.7 x minus 13.7 plus 14. Where did the plus 14 come from? I brought it from one side over to the other. And now when I simplify, I get y equals 13.7 x plus 0.3. And that right there is my equation of my tangent line, which is right there. And so if you look, you can see the equation of the curve, you can see the point that they both share, which is what tangent means, and then you can see the tangent line. And the tangent line and the curve have the same slope at that point, which is 13.7 approximately. Okay, so for your exit ticket, you're going to look at the very next slide, and we'll talk about it. Okay, this is your exit ticket, and for your exit ticket, you're going to do this on notebook paper, and then you're going to upload it to Blackboard, and I believe it's exit ticket number 10 for the semester. So again, it's just like the one we just did, maybe a little easier. Only difference is I don't give you the original y value, so you need to find f of 3. You need to find f of 3 first, then you need to find the derivative, and then you need to find the slope over the derivative at 3. And then you need to find the tangent line. So you're going to do all this on notebook paper, and then you're going to upload that to Blackboard. Your homework is 11 problems that you can find on My Math Lab. I put the due date on Blackboard, so you can look at the due date. All right, guys, we had our first class. I wish you luck. Text, call me, email me if you have any issues. I will see you later. Bye.